Hello everybody, this is Mr. Blevins again, and we're doing another problem from the 2-3 homework set. Once again, this is the epsilon delta, is what I like to call epsilon delta definition of a limit. When you hear epsilon delta, I'm saying epsilon first, okay? So epsilon is given first, and then we use epsilon to find delta. Okay, so epsilon delta. So what am I doing here? Epsilon is 2, so I can see that I'm going up 2 and down 2 from our limit of 4. So up 2 would be 6, down 2 would be 2. And we want to come up with what value of delta, the two deltas, our delta 1 and our delta 2. I'll give us some space here. Based on where they're making contact, this is C is corresponding to this point 2 here. And so basically what we're trying to find out is how far away these points are from C. Horizontally, that's what these delta 1 and delta 2s are. The horizontal distance between C, again, which is 2, right, and these two other numbers. Now it gives me the two lower and upper numbers on this, but sometimes you have to find it yourself. So if they didn't give me this square root of 2 and square root of 6, how would I find it? Well, I would add 2 and subtract 2 from L. So adding 2 would give me 6, subtracting 2 would give me 2. And then I'm taking, those are the y coordinates. All right, those are y's because we're adding 2 and subtracting 2 from a y. And then we're just setting the function equal to that to figure out what the x's are. So x squared is equal to 6. So x is equal to technically plus or minus the square root of 6, but since we're over to the right, we're not dealing with these points over here. So we're dealing with the positive square root of 6. And then likewise, when I subtract 2 from 4, I would get x squared is equal to 2. I would get the square root of 2. Okay, so what is delta 1? What is delta 2? Well, they are how far these two numbers, square root of 2, square root of 6, are from the number in the middle, the C. So how far are they? Well, the square root of 2 is smaller, so that's going to be delta 1 and delta 2 are positive values. So that is the 2 minus the square root of 2. And I always call delta 1 the one to the left. Delta 2 would be the one to the right, so that's going to be the square root of 6 minus 2. Alright, now which delta we want? Which? Find delta. Again, it's not both of them, it's the smallest one. So then we have to figure out, well, which one of these is smaller. Alright, now I've got Desmos up. This is how I suggest you guys practice this. Alright, if you want to subtract and just get a number, you just type it in just as you would an equation for it to graph. It does work just like a regular calculator. So you can write 2 minus, for square root, there's a couple ways. You can come down here and you can use the square root key and you can get 2, but you can also do the keyboard shortcut SQR, and I'm getting ready to write the letter T, but as soon as I write T, it changes to a square root symbol. And then I can type in 6, come out from under the square root sign, minus 2, and there's our two numbers. So this is delta 1, this is delta 2. Delta 2 is smaller than delta 1. Okay, so this is the one we're after, the square root of 6 minus 2. So what would delta be here? Delta would be delta 2, which is the square root of 6 minus 2. Now what does that mean that I picked that one, not the other one? Well, it's hard to see when the image is so small. Let me see if I can erase some of this stuff and blow it up a little bit. But what we're just basically said is that this, again, I mentioned it in the last Desmos lab, when we go up and down the exact same distance, this is our epsilon. We went up epsilon, we went down epsilon. When the graph curves and bends and twists and it's not a straight line, the gap, we went up the same as we went down. But the point that corresponds to that down here, the x-coordinate, because it bends, we will not go left and right the same, even though we went up and down the same. And because this part right here is steeper than this part right here, we went up and down the same, but we didn't have to go as far right to go up the same as we went down, because it's steeper. So this little part is smaller. Okay? And so again, ultimately what that means is we want to guarantee that we are within the epsilon window. So if we went right and left that much, we would be guaranteed that we would always fall in the window on both sides, even though we have, we didn't quite get over far enough on the right. We didn't get as far to the left as we could have, according to this point. But we're guaranteed to be in the window with that delta. But if we went with this delta on the right and left, we'd actually go out of our window a little bit. And again, now we're no longer guaranteed to be within epsilon of the given limit. So that's why we do this. That's why we pick, with epsilon we get two deltas. We find out which delta is the smaller delta and we go with that one.